Hi everyone, hopefully everyone can hear me okay. I think nearly everyone's joined the webinar, so we'll get started. Firstly, welcome and thank you for attending this webinar. This is a webinar following on from our earlier automation webinars, specifically looking at the future of test automation. This webinar was first delivered at a cross-industry seminar we ran in London in November 2018, and at the end of that session a number of people came up to me afterwards and asked if we could deliver this as a webinar, so here we are today. A little about me: I'm Ash Gawthorpe, one of the co-founders of Ten10. My background is in hardware and software engineering, development and architecture, with lots of experience in technical testing and performance testing. In the interest of time, we'll be rattling through this at some pace. If you don't quite understand or perhaps miss something, this webinar will be available for streaming from our website at a later date, so you will have the opportunity to revisit it again at a later time. As always with these webinars, if you have a question, please enter it in the chat window and we'll try to answer the question in this session. There are quite a number of people on here today, so if we don't have time to answer them on the actual call itself, we'll make sure that we reply to each of you individually. So we have 30 minutes today, and we're specifically going to be looking at exploring the three key questions. Firstly, can a software engineer essentially replace the role of a test analyst, and can automation replace the requirement for manual testing? We're then going to look at how the new generation of AI automation tools that we're starting to see appear, how that will impact the role of the test automation engineer. And finally, we're going to look at how automation and testing generally will be impacted by the increasing number of systems using AI and machine learning, and how this will change the game essentially. In order to answer the first question, I'd like to break down the key activities required in running a test automation project. So starting from the top then, firstly we need to work out what it is that we should actually be testing. We then need to create elegant tests to achieve the right level of test coverage, and in this case less is definitely more. We also need to ensure that we are asserting on the correct elements. Are the tests effective, essentially? We then need to concern ourselves with identifying, selecting, reading, and interacting with the required elements in order for the test to be effective. We need to maintain the scripts as changes occur over time. And lastly, but by no means least, we need to decommission the test script or rewrite it when it's no longer effective, or perhaps consider refactoring or combining that test into other tests. The end result is test execution. Automation in this case is just a way of executing those tests in a fast and repeatable fashion. So if you think about this list in a little bit more detail, how many of these activities don't relate to the role of a test analyst? In my mind, it's really just numbers 4 and 5. These are the techie parts. Arguably, point 2 can also have a technical element to it. There's likely to be an elegant technical solution to minimize the amount of code that we run and the amount of code we need to maintain. One common anti-pattern here is the view that more tests are good. Surely 100 tests is 10 times better than 10 tests. Not necessarily. Less is very much more here. Bear in mind that every time you write a test, you're creating a legacy that has to be maintained. You're essentially adding technical debt. If you can achieve the same level of coverage with 10 tests rather than 100, then go for the 10 every time. This is sometimes, however, slightly counterintuitive, and you need to ensure that the goal is to test the application, not to write lots of tests. So in summary then, 1, 2, 3, and 6 need to apply whether you're automating or not. In answer to the question then, can a software engineer essentially replace the role of a test analyst? I'd say definitely not. In fact, I'd actually go further than that. We see a lot of automation projects and we see many of them fail. Now, some of them fail for technical reasons, and I'll come on to this next, but very often they fail because individuals have jumped straight into the technical challenge of writing code. The more code, the better, the more tests, the better. And as a result of that, they've lost sight of good test analysis. In fact, Whenever our consulting teams begin a test automation project with a client, we mandate that a senior test analyst reviews the existing test assets, ensuring that they're fit for purpose, that they're not duplicating their functional coverage, and each test is signed off on to ensure that it's fit for purpose and indeed automatable before it's added to the backlog for automation. I'd just like to quickly lift the lid on creating automated tests and look at a simple maturity model for both the automated test team creating the tests, but also the automation awareness of the development team creating the app. And the two need to work together in order for your automation to be effective. So each one of these has three levels. So if we consider the test team first of all, step one is really record and playback. So this is a little bit of a nightmare. It's not robust, it's susceptible to any change, and it's likely that when the app does change, you'll need to change every occurrence of every interaction with that element that you recorded. It probably also relies on implicit waits. So your automated tests just have maybe wait for 30 seconds in there before they test an assertion. This slows down your tests. Step two is where you start to employ those good software development practices. So this is all around encapsulation of code and abstraction, perhaps using some common design patterns such as the page object model to separate your element interaction code from your test code. So if you find a problem, now you're really just having to change it in one place, which greatly reduces maintenance. You're probably also using explicit waits. So you're not waiting for a particular time period, you're waiting for a condition to occur before you then do your assertion. So waiting for something to happen or something to appear. Step three is really where you start to build in defensive code and multiple interaction methods with those elements. So for example, I've recalled projects in the past, and Silverlight used to be a devil for this, where you would click on an element, you'd find an element, you click on an element, and it simply wouldn't move on. You'd ask it to click on a button, and it only would 8 times out of 10 with no good reason. So you find yourself writing defensive code to wrap around that button click to take that into consideration. So it's checking to see the state has moved before it's confirming that that button has clicked. Also, perhaps it can't detect an element, for example. So if you have multiple interaction methods with those elements, one of which is a good fallback is to be able to, rather than relying on finding it at the object level, you find it based on bitmap matching. And if you find that you can't click on something or you can't interact with it, then you physically move the mouse pointer over it and tell it to click the left button. So this adds complexity to your code, but essentially it does make it far more robust and it makes the test runs more reliable. I mean, hopefully your applications and the test don't warrant that kind of level of defensive code. So let's overlay on this the dev team maturity. So step one, and we see fewer occurrences of this nowadays, but it still does exist. So this is where the dev team's kind of pushing back and saying, well, what's testing? What's the point? We do that. What's test automation? Why on earth would you want to do that? Perhaps the tools that you're using or the tech that you're having to test, maybe that requires libraries to be built in for an automation tool to work, or perhaps it requires a change to the build process for that device to be accessible by the automation tools, for example. There's often an unwillingness to change that process, and also an unwillingness to set any IDs on any controls, which would make it far easier to locate and interact with those elements, automation IDs, for example. Step two is the next step along, where the development team, they kind of get it, they understand why and the reasons behind you doing it, and they're willing to add automation IDs, they're willing to change the build process as required, but one challenge here is that whilst there's that willingness to change, they lack the discipline to enforce these changes consistently. So this is almost the most dangerous, because it means that you'll have a change and your test scripts will work fine with that, and then they'll deploy another build, and you'll realize that perhaps all the automation IDs have been reset, or they've failed to build those libraries into the build process, or the build process hasn't been correctly adjusted. That takes a lot of time and a lot of toing and froing. You then move on to step three, which is where the development team does have that discipline, but also it also understands the impact downstream and proactively works with the team to set out how to make the app more automatable. And we've seen numerous occurrences of this over the years where, for example, a control is very hard to find, or maybe it can exist in different places, and the dev team have been able to step in and make that control far, far easier to find. Now, hopefully, your test teams are three and your dev teams are three. However, often that's not the case. And there's particularly a great deal of frustration if you're a three and the dev team you're working with is a one. And this might not just be one app, of course, it might be in a large organization, multiple dev teams for multiple different suppliers, all of whom have a varying level of maturity, and all need to be considered and acted on, and the estimates around how much time it's going to take to maintain the scripts adjusted accordingly. Is automation always the answer then? There's a fairly standard view for return on investment based on a number of variables. So these include how many times do you run the tests, how long does it take to execute each test run, how much does the application change, and how long before the application is replaced, perhaps end of life, or a new front end is created. How many scripts do you need to write, and also how many steps are there in each script, and how long does it take to write each step on average. And then finally, how much maintenance is required. Now, this is all fairly standard stuff. If you run the numbers and all of those variables, and it clearly shows that you're going to get a good return on investment, then go for it. If it doesn't, then test automation probably isn't viable in this example. And in these cases, manual testing is still required. So in answer to that question, can automation replace the requirement for manual testing? It would seem not, or at least not yet. However, we need to clearly differentiate here between manual testing because automation isn't worth it versus manual testing because it's viable in its own right, which we'll come on to in a second. So therefore, it seems there's actually the potential for more projects to be automated, but we can't because it doesn't quite make the return on investment case. What if you're somewhere in the middle then? What if you run those numbers and it doesn't quite indicate that there will be a good return on investment and that automation is viable? What would happen if we were able to reduce the amount of time taken to write those tests, or if we're able to reduce the amount of maintenance required between those changes? If we were to lower those variables, then that would bring automation under the threshold, meaning that we would be able to get a good return on investment and automation would be viable. We're going to look now at some examples where automation tools using AI and machine learning are able to speed up test creation and also reduce the time spent maintaining scripts. So through this process, we expect applications where there wasn't an ROI case to increasingly become in scope for automation. So where does this leave the role of manual testing then? In my mind, manual testing, by that I mean manually executing the same scripts over and over again, will reduce over time. As I said earlier though, manual testing is very different to test execution performed by a human. Exploratory testing, spotting anomalies and patterns above and beyond what the scripts are asserting on, or looking at visual changes, these things are still very valuable. The other thing we're going to look at is where the next generation of AI tools are able to perform these tasks that traditionally have only been able to be performed by a human as well. When people talk about artificial intelligence, what springs to mind? Maybe something like HAL from 2001, or maybe number 5 from Short Circuit, or perhaps something a little more contemporary such as Alexa or Siri. But just to be clear, we're talking about machine learning here, which is a very particular subset of AI. And at its core, machine learning is about pattern recognition. It's very good at finding patterns in data. It can then use those patterns identified by your machine learning algorithms to predict future trends. In order to do this, you need data sets of a size that are impossible for people to go through, and at that size it's impossible for them to detect the repetitions and the patterns within it. This is what makes the machine part of machine learning so powerful. It's able to consume huge amounts of data, find the predictive patterns, and then alert on deviations from those patterns. And I want to look at how can AI and machine learning be used in testing. I wanted to keep this as applicable to the real world as possible. There are lots of new developments in AI with organizations working on things, some of which are quite theoretical. I wanted to ground this in practical examples that can make a tangible difference and add value to test automation now, today. I'm going to split this into two key considerations. Firstly, how can AI and ML add additional benefits and insights around automated testing? And secondly, and perhaps more importantly, how can it reduce the time taken to write tests and also decrease maintenance between builds in order to make automation a viable proposition for more applications? The first point I'd like to run through is around automation of visual validation of an application. So this isn't checking functionality, but it's checking that visually everything is where it should be, that controls are the correct color, they're the correct shape, the correct size, and also that they're accessible. We had a problem we came across where we had an automated test script which ran on an application. The automated test script was able to inject text into a username text box, and the test passed, but the user wasn't actually able to focus on that control. When they clicked on it, they weren't actually able to enter text in that text box. So you want to be able to pick up on that kind of thing and also ensure that the various controls don't overlap. As well as controls, you want to be able to do that for components on the page or in the app that change as well. So for ads, for example, on the screen, the content within those ads will change each time, but their position and the control of that position needs to be maintained across all the different builds. This is becoming increasingly important where testing needs to be performed on a vastly expanding array of different browser versions, different device types, with different operating systems. And all of those are running on devices with different screen resolutions and different pixel densities. So this is where machine-based visual validation tools like Applitools are able to pick up the slack and do some of that heavy lifting. And there's just a little video demo here of Applitools just doing exactly that. My next point is around optimizing execution and also being able to focus the effort to fix failures accurately through the use of machine learning. So imagine a scenario where you have your automated test pack, you're executing the tests regularly, if not continuously, and you seem quite happy with that scenario. It seems to be working pretty well. Whenever you run the tests, the test run itself and the app or applications that it's exercising produces lots and lots of data in a myriad of reports and log files and various other structures. So what do you do with this data? So in our experience, the answer is that when the tests pass and everything's green, very, very little. When tests fail, then we might search through a sequence of screenshots created through the test, or perhaps trace through various log files to see where the errors were generated and perhaps try to correlate those things together. This is the way that we've worked for years, under the old mantra of if it ain't broke, don't fix it. But what if those gigabytes and gigabytes of log files and other information actually contain useful insights and could be brought to bear to make the whole process of running tests, and also when we find issues with tests, resolving those far faster? Machine learning can be applied here too, as we discussed. It's able to process very, very large data sets and to correlate them and look for patterns within them very, very quickly. So it can be used to indicate which failures are duplicates and which are existing and which are new, and also to know what code's changed. So by correlating timestamps and entries in log files with test failures and screenshots, it's able to spot those patterns. Perhaps, for example, there's a threading issue where a failure occurs. So the log file, the ordering of entries are slightly different. Perhaps there's a button present on the screen earlier that was grayed out when the failures occur. All of these patterns would be very, very difficult, if not impossible, for a person to spot. But this is bread and butter stuff to the appropriate machine learning algorithm. It can't fix the underlying errors indicated by these patterns, nor can it work out if it's an actual issue, but it can raise them for a human to review and then decide whether it warrants further investigation. Essentially, this can very quickly expedite the resolution of defects and also help understand whether underlying issues relate to one or perhaps a more complex number of defects interacting together. So this ensures that your finite and bandwidth constrained developers and testers can be deployed and focused in the right area, speeding up the prioritization and resolution of failures. It can also help guide you on a minimum set of tests to exercise a particular problem area of the application, only running the tests you need to. Because while this test pack is automated, it may still take a considerable amount of time to run through. And if you're able to slice that up and target particular problem areas and just run those tests, then that's very advantageous. This next point here is around spidering. So you simply point the tool at your website or application and it spiders its way through it, capturing screenshots, downloading HTML, measuring load times, measuring the number of round trips and payload sizes, a whole variety of different metrics that it captures. And it runs through this time and time again. And each time it does, it's building a data set and training the machine learning algorithm on what your app looks like and what the expected patterns are. When the app is changed and it runs through that again, it then compares its current scan to all the patterns that it's learned previously, and it's able to spot differences and to raise anomalies. For example, say there's a visual change to it, as we talked about before, it's able to flag this to a human for confirming whether it's an actual valid change or not. Now, this functionality is very handy, but I see the real value in these tools through flagging patterns and changes that aren't visual, that the human can easily see. So, for example, and this is a concrete example we came across, say you've been running a nice streamlined release version of a JavaScript library on your site, and then for whatever reason on that build, the deployment function has a bit of a hiccup. And instead of deploying that release version, it deploys the full-fat debug version of the library. And instead of minifying and compressing all the code there, it doesn't. So in practice, what that means is that instead of it doing about 20 round trips and about 200k of information it's pulling backwards and forwards, it ends up doing 200 round trips and about 2 megabytes of data. Now, would you or your test engineers spot this? Would you spot it, especially when you're when you're testing on an application which is connected to a test environment over gigabit Ethernet in the office? The answer is normally no. Or would your users spot it when it goes live and it's slow to access over a mobile network? Or perhaps when the first you hear about it is that the forums are filling up with people talking about how this latest release is chewing through their monthly data allowance in next to no time at all. So it can be very, very useful for that kind of thing. I do have a question here though, or at least a word of caution. On the face of it, it's kind of writing its own tests. It's producing its own knowledge around how it believes the app should be working and kind of asserting against that, or at least raising issues where it isn't as it sees it should be. So are we back to the idea of proliferation of tests here? Are we testing lots of different things, but are we actually testing and asserting on the right things? So in my view, deviances like this should be raised for checking with people. So if we think about it, in effect, yes, it is writing its own tests, it's running them, but then equally it's flagging it up. So then there's a person that's actually looks at this to say whether they believe this is a real defect or issue, or whether it's something that really shouldn't be concerned around. So from that point of view, tools like this I think of more as a safety net than a primary or maybe even a sole form of testing deployed on a particular application. We still need good test analysts to ensure we're testing the right things, and those data models can provide great insights, but we still need test analysis to determine whether the action is actually correct and what we're looking for or not. So I guess in summary, that good tests still stand, otherwise it's just producing a load of info that's not very insightful. For me, the point on this slide covers where machine learning is able to add the most practical benefit to test automation at the moment, and that's to work to reduce maintenance. If you recall the slides I mentioned before around maturity within test and dev teams, if you're writing your test properly and your dev function's behaving itself, then you can minimize maintenance, but you can't eliminate it. When we are selecting elements, we generally just use one selector or path. For example, the control with an automation ID that is X, or the control of type text box with a default text value of username. It's these assumptions that we bake into the app that cause our tests to break when changes are made. Nearly all conventional automation tools work using this technique, rigidly coupling elements to selectors, making scripts brittle. As I said, hopefully your dev team won't reset the automation IDs each build, and you have access to the control referenced in a page object nicely abstracted away so you can change it in one place if you need to. However, AI tools can make machine learning help with this and take it one step further. The tool is constantly learning about your app, understanding relationships between parts of the DOM and how it changes over time. It can then start to make decisions at runtime as to what locators or combination of locators best define an element. As your app changes, it's no longer a problem as the script automatically adjusts itself. But AI tools can make use of machine learning to automatically adjust these variables and to adjust to these changes. So this makes our tests more maintainable and reliable. So for example, current AI ML tools are able to start learning about your application, understanding relationships between the different parts of the DOM, and learning about changes throughout time. Once it starts learning and observing how the application changes, then it can make decisions automatically as to what locators it should use to identify an element, all without you having to do anything. And if your application keeps changing, then it's no longer a problem because the learning script can automatically adjust itself. Again, one word of caution here though, for me it's a question of control. What if the app decides on the wrong element, perhaps leading to an incorrect result from a test? Tools such as Mabel are there to help and designed with this in mind. And whilst they are very, very useful, they still require interaction with a person to be able to check and validate what it is that they're doing. However, that said, this is the area, in fact, where I can see AI adding the most immediate value to automation. So far, we talked about how AI and ML can change test automation. On the flip side, what I'd like to talk about here is testing systems that use artificial intelligence or machine learning. And it's very different. In fact, from my point of view, I see this as a bit of a game changer, really. We've moved away from a place where you set up your test, you run your test, and you assert on a single or a number of conditions. Crucially, these are always deterministic. If I enter a correct username and password, then I'd expect to log in. If I ask an application to find the number of red shirts in size large, assuming there are 20 in stock, then it should tell me there are 20 in stock. Fairly simple checks, and I guess at the root of everything that we do within testing. That changes. We're moving away from those deterministic outcomes into dealing with non-deterministic systems. So we're moving away from certainties and into the probability of outcomes. This is also made doubly difficult by the fact that the system learns and changes as you're going along and as you are running those tests. So the outcomes can change depending on the tests you've run and how the internal models have changed over time as a result of that data. So, for example, within the legal sector, there are a number of AI systems coming along that would do the role traditionally done or performed by teams of junior lawyers as part of a due diligence process arising ahead of an acquisition or a merger. So parsing through huge amounts of documentation, checking for change in control and various other sort of clauses that would be flagged up and would be raised as a concern. The question that one of the big challenges for me is kind of what happens if you're running this system and its internal rules change. So, for example, if it starts letting things through that perhaps it shouldn't, who's checking that? So that raises the question of whether you need to test in production against a data set to ensure that it's still behaving in the way that you'd expect it to do against a training set of data. I guess it also raises the question of whether you in fact need multiple systems all working concurrently and voting on the outcome to determine whether something should be raised or something shouldn't be. The other game changer is that these systems are generally not at all GUI based. They're all API based with the testing focused on this. There's a lot of analytics required in the test scripts. In the same way as automation required testers who can code, this has moved from a specialist area to the normal expectation now that all testers should be able to code, at least at some level, at least be able to read code. I think we're at a similar crossroads again. The adoption of AI and ML is gaining momentum. And I think this will get to a point where nearly all applications or systems are using it, or at least some aspects of it. Additionally, the next generation of automation tools having at least some element of AI and ML are here already, and the benefits they can bring, if used in the right way, will be adopted by other tools as well. So I think, therefore, we need testers who understand AI and ML and the underlying data models and the different types of algorithms that can be brought to bear, and the various advantages and disadvantages of each one according to the type of work that you're looking at doing. So what do I think this is going to mean for the test automators moving forward? As ever, I think there's a need to adapt, to develop new skills, but then this has always been the case. I don't see us getting to a point anytime soon where AI will remove the need for test automation engineers, nor do I think we'll get to the point where the tools can automate all of the automated scripts themselves. But I think they can help remove some of the drudge work of maintenance, freeing up people to work on more insightful, higher value work. Okay, so that's about all we have time for today. Apologies, I have run over the half hour slightly. So what I think we'll do is we will look through the questions offline and get back to people that have asked questions individually. As I mentioned at the start, if you'd like to sort of revisit this in any way, we will shortly be making this webinar available for streaming on the Ten10 website. So really, it just remains to me to say thank you very much for attending today. I hope that's been useful. I hope you've perhaps learned something from it. And have a good day. And I look forward to maybe catching you next time when we do another one of these. Lovely. Thanks very much. Bye.